Hello friends, myself R.D. Mahajan, Assistant Professor MIT Aurangabad, presenting my next video on the topic Inverse Laplace Transform by partial fraction method, case third, when factors are real and quadratic. I will explain it by solving two examples, simple examples. Example number 1. Find inverse Laplace of 3s plus 1 divided by s minus 1 into s square plus 1. Three s plus 1 divided by s minus 1 into s square plus 1. In denominator we have two factors, s minus 1 and s square plus 1. The second factor is in the form of quadratic, and therefore how to obtain the partial fraction. But first we check whether it is proper fraction or not. Degree of numerator is here 1 and degree of denominator term is 3. 1 less than 3 means it is a proper fraction. And as it is proper fraction, we can apply partial fraction method or technique. That 3s plus 1 divided by s minus 1 and s square plus 1 we write down as for this non-repeated, as per case 1, it is a upon first factor, and for this quadratic way to write partial fraction is b s plus c divided by s square plus 1, and we call this as equation 1. And then finding LCM. Finding LCM, we get 3s plus 1 is equals to LCM is this product s square plus 1 into s minus 1, and therefore dividing by this s minus 1 to this LCM, s minus 1 get cancelled, remains s square plus 1, multiply by that to a, therefore a into s square plus 1, dividing by this s square plus 1 to this, s square plus 1 get cancelled, s minus 1 remains, multiply by that to bs plus c. And then simplifying it by collecting the terms of s square, s and constant term. Therefore, in first bracket I will write down the terms of s square. Here it is a into s square, and if you multiply this, it is b into s square, means b into s square. Okay. Then terms of s, here it is constant term, bs into minus 1 means minus bs, and this cs, therefore c into s and minus bs, taking s common, we get c minus b into s. And then constant terms are here, a into 1 means a, here the product c into minus 1, we get minus c. Okay. Then comparing two sides, means comparing the coefficient of s square with this s square term on left, comparing coefficient of s with coefficient of s on left, and constant term with constant term. We get here the coefficient of s square is a plus b, and no term of s square, therefore value is 0 here. The coefficient of s is c minus b, and the coefficient of s is here 3 on left, therefore equating it to 3, and the constant term is a minus c, and that is equals to here 1. Therefore we have three simultaneous equations. Solving it, we get from a, from first we get the value of a as minus b, okay, and if we put that value b as here minus a, this second becomes c minus b, and the value of b is minus a, that minus and this minus, it become plus a, is equals to 3, and here it is a minus c, therefore minus c plus a, or a minus c, is equals to 1, and therefore adding this to this cc get cancelled, we get a plus a 2a, and addition of this 3 plus 1 4, it gives you a is equals to 4 by 2, that is 2. A is equals to, we get 2, and therefore we get b is equals to minus a, and therefore it is minus 2, okay, and if we put that value of a in this equation, or in this equation, in any, we get the value of c as, I will put that here, c is equals to, transferring to right and this to left, it is a minus 1, and therefore the value of a is 2, 2 minus 1, we get that value of a c as 1. Therefore we get a is equals to 2, b is equals to minus 2, and c is equals to 1. Substituting these values in 1, equation 1 becomes and therefore left hand side is here 3s plus 1 divided by s minus 1 s square plus 1 is equals to the value of a, we have 2 divided by s minus 1 plus the value of b minus 2 s plus c, c is 1, and divided by s square plus 1, okay, and then taking inverse on both sides, inverse of left hand side and inverse of right hand side, and while taking inverse on right hand side, we take the individual inverse of the first term and inverse of second term. Okay, and therefore it is equals to uh, two constant we can take outside as per property of linearity. Inverse Laplace of 1 upon s minus 1 here it is minus 2 constant outside, inverse Laplace of dividing separately, it is s upon s square plus 1 and 1 upon this, therefore it is inverse Laplace of 1 upon s square plus 1. Okay, and therefore applying standard results of inverse Laplace transform, we get to 1 upon s minus a, its inverse is e raised to at, and here a is 1, therefore it is e raised to t minus 2 times s upon s square plus 1, its inverse is cos at, a is here 1, therefore it is cos of t plus inverse of 1 upon s square plus a square, its inverse is 1 by a sine of at, a is here 1, therefore 1 by 1 1, and sine of at is 1, therefore sine t, and inverse of left hand side f bar of s, its inverse is f of t. Okay, this is the required answer. And what results we have used? Since for the first, it is, we know that inverse Laplace of 1 upon s minus e is e raised to at. Using this we get this one. Second, inverse Laplace of s upon s square plus 1 as cos of at, and the third, inverse Laplace of s 1 upon s square plus a square as 1 by a sine of at. Therefore, these three standard results I have applied to obtain this required answer. Therefore, that standard results are very, very important throughout the chapter or throughout the discussions of inverse Laplace transform. Second example, find inverse Laplace of 5s plus 3 divided by s square plus 2s plus 5 s square plus 2s plus 5, and the second factor is s minus 1. Here it is denominator with two factors, two terms. First one is s square plus 2s plus 5 in the form of quadratic, and second factor is s minus 1. And as it involves quadratic factor, it becomes case number 3, and therefore we apply that technique. Here the degree of numerator term is 1 and degree of denominator is 3, 1 less than 3. means it is a proper fraction, and as it is proper fraction, we can use partial fraction technique. Therefore, this 5s plus 3 divided by quadratic factor s square plus 2s plus 5 into s minus 1 as a upon this is quadratic factor, therefore as per that it is as plus b divided by that factor s square plus 2s plus 5, and for this non-repeated, next that is c upon s minus 1. We call this as equation 1. And then finding LCM. LCM is this product. Therefore, dividing by this term get cancelled, remains s minus 1. Multiply by that to this, and therefore we get 5s plus 3 is equals to that as plus b multiplied by s minus 1 plus dividing by this s minus 1 get cancelled, this remains, therefore multiplying by that to this c into, we get s square plus 2s plus 5. Okay, and simplifying it, therefore multiplying term by term, we get a into s square minus as plus bs and minus b. These are the 4 terms after performing product. Then c into s square plus 2cs and plus 5c. Okay, and then once again collecting the terms of s square in the first bracket, 2 terms are there, therefore a plus c into s square common. Then collecting the terms of s, 1, 2, 3 terms are there, therefore from that I will take s common. Here it is b minus a and plus 2c, and last bracket for the constant term, minus b is one constant and second is 5c. Always we write positive as the first term, therefore 5c minus b, and then comparing. Two sides. Coefficient of s square is a plus c. We get a plus c is equals to no term of s square, therefore we equate it to 0. Coefficient of s is this b minus a plus 2c, and the coefficient of s is a 5, and last constant term 5c minus b, and here it is 3. Therefore, solving it simultaneously, we get from first the value of a as minus c. Okay, if we put that in this equation, we get second equation becomes b minus a is minus c, and that minus it becomes plus c plus 2c, and that is equals to 5. Therefore, we get b plus 3c. b plus 3c is equals to 5, And the last third equation is minus b plus 5c is equals to 3. Adding these two, therefore minus b plus b get cancelled. Addition of 5c plus 3c, we get 8c, as 5 plus 3 8, and we get therefore c is equals to 8 by 8 1. We get the value of c a plus b is equals to okay. Then put that value of c here, we get therefore a is equals to minus c means minus 1. Okay, and if we put the value of c here, we get the value of b. Transferring this to other side, we get b is equals to 5c minus 3. The value of c is 1, therefore 5 minus 3, we get that value as 2. Therefore, substituting these values in equation 1, equation 1 becomes okay, and therefore left hand side is 5s plus 3 divided by s square plus 2s plus 5, and second term is s minus 1 is equals to a. The value of a is here minus 1, therefore minus s plus b. The value of b is 2, therefore minus s plus 2 means 2 minus s, and divided by s square plus 2s plus 5, and c, the value of c is 1 upon s minus 1. Okay, then taking inverse on both sides, therefore left hand side inverse and right hand side inverse. Okay, and then we find the if we call this as equation 2, we calculate the inverse of this and inverse of this separately. Therefore, I will first write down the inverse of this. Inverse of 1 upon s minus 1 by standard result is e raised to at. A is here 1, and therefore it is e raised to t. And to find the inverse of this, factors are not possible for this. Therefore, we try to convert into perfect square by calculating last term. If we consider first two terms, therefore we find last term as middle term square divided by 4 into first term by that technique. Therefore, here middle term is 2s, its square is 4s square, and divided by 4 into first term. Therefore, it is, therefore add this term as well as subtract it, and therefore this term s square plus 2s plus 5 we can rewrite as s square plus 2s plus 1, we add it and we subtract it, and plus original 5. This first three terms, s square plus 2s plus 1, is a perfect square of s plus 1. Therefore, if we square it, we get s square, twice a be 2s, and plus b square means 1. And 5 minus 1, that is 4. 4 means 2 square. Okay. And therefore, we put that value here, means we replace this term by this term, and then we can find inverse. And therefore, finding is inverse separately. Inverse Laplace of 2 minus s divided by s square plus 2s plus 5 means inverse Laplace of 2 minus s divided by this term I will replace by this one. Therefore, it is s plus 1 square plus 2 square. Okay. I will take minus sign common from this. Therefore, it is minus inverse Laplace of s minus 2 divided by s plus 1 bracket square plus 2 square. Then here in denominator s is replaced by s plus 1. Therefore, everywhere s must be replaced by s plus 1. Therefore, I will rewrite this adding 1 and subtracting 1, so that no change in this original value, and this minus 2 divided by s plus 1 square plus 2 square. And therefore, it is equals to minus inverse Laplace of s plus 1 divided by, I am taking separate division, it is s plus 1 bracket square plus 2 square and this minus it become plus 3 constant outside, inverse Laplace of 1 upon s plus 1 square plus 2 square. Okay. As s replaced by s plus 1, it becomes a problem of shifting theorem, and therefore as per that shifting theorem it is minus e raised to minus at a is 1, therefore e raised to minus t into inverse Laplace of remaining term. What is, if you neglect this one, it is s upon s square plus a square. Its inverse is cos of 80. Therefore, it is cos of a is here 2. Therefore, this is the inverse. And the second one, again s replaced by s plus 1 by shifting theorem, e raised to minus 80. And if we neglect, it is 1 upon s square plus a square. Inverse of that term is sine 80 by a is here 2. And this is on left hand side. Inverse of this term is f of t. This is the inverse for the first term. Therefore, substituting the values here in equation 2, that equation 2 becomes, therefore, inverse of this is f of t. Inverse of the first term is this one, it is 3 by 2 e raised to minus t sine 2t. minus e raised to minus t cos of 2t